Yeah. Sorry,
Yeah.
sir.
So again, then basically you so then what is tan x?
Uh,
See, here you have a sin x, right? You should
Right.
write this in terms of sin x. What is tan x?
Sin x by cos x.
Right? So that means this is
Oh, right.
now you apply here. You write 0 plus, right? Cos x by sin x, right?
Right, sir. Into sin 4x.
Now how next for what you should do? Any idea?
Differentiation.
Yeah. So what sort of differentiation you want to do?
Like it is fx by gx. So first of all,
What is f of x?
Cos x, sir. In the first part, cos x by sin x, na. We will do fx by gx. The rule you tell, product. No, not product. It is a rule of chain rule.
Division rule.
Division rule, right?
Tell me. Yeah, how I should do that.
The derivative of fx into gx.
So you want to so what you want to so what is that rule? Tell me the name of that rule. Which rule you want to apply here?
Give me a second.
Sir,
The quotient rule. Quotient rule,
get,
sir.
yeah, quotient rule. In the division, we get the square of the square
Quotient
of
rule.
in the yeah.
You are not computing derivative. You are computing the limit, right?
Sir, L'Hopital rule.
Yeah, you tell me that that is what I am asking you. That is L'Hopital rule, quotient rule. See, you simply you can't forget the name of this rule, right? This is this is what you are doing only because this whole lecture 3.4 or this is all about L'Hopital rule. If you forget the name, then there is no point. Okay, so if I apply a L'Hopital rule, then what? See, you basically how you apply for intermediate form, right?
Yes, sir. 0 by 0 or indefinite by.
So when you apply this limit extends to 0, okay, so you must have some form, right? F of x by g of x,
Right, sir. Right,
so
sir.
what is f of x and g of x here for this whole expression? What is f of x and what is g of x? What is f of x for this expression? What is f of x?
Cos x, sir.
Cos x. Okay. And what is g of x?
Sin x.
Sin x. Okay. Sin x. Okay. So if I take f of x equal to cos x, g of x equal to sin x, then is it in an intermediate form?
No, sir.
Then how you are going to apply L'Hopital rule?
Sir, it will be cos x
let him
into
answer
sin
the
x.
question. Let him
Okay.
answer the question. Yeah. Since you have asked, see, if you are asking, then you must have spent a lot of time on solving that question, right? So
Yes,
tell
sir.
me, yeah. So then what you should do then?
Okay, so like we take the differentiation of fx divided by differentiation.
You can't apply L'Hopital rule, right? See, if you take f of x equal to cos x and this is equal to sin x, then basically you are in 1 by 0 form, right?
Okay.
You can't apply L'Hopital rule.
Sin 0 is 0. Okay. So we have to change this in something.
Yeah, change. Yeah, how you are going to change?
Sin x will be converted into cos x.
Yeah, now you try to think. Okay, I have given you a lot of hints. Now you try to think how you can do it.
Okay, sir.
Okay.
I think, sir, is solved by 10x into sin 4x.
Sorry.
Not cot x. Cot x into sin 4x, so that it will solve, I think.
Sorry.
the cos by sine, it is cot x, na? Cos by. So we can solve like that. Cot
Yeah,
x into sine 4x.
Yeah, tell me how I can solve that.
Yeah.
Tell
Limit
me
x
what.
tending to wait, I will solve then I say. Yeah,
Sorry.
sir. First of all, we write cot x into sine of 4x. So apply here product rule. So
What product
in
rule
sine,
you will apply? So okay, so you are basically saying I am basically
Sir,
in,
can I answer? I have some easy way of, I think.
yeah. Uh,
here
the-
apply in
We
sine
can
4x.
take
here
the
apply
whole
tan rule.
numerator as fx and the denominator as gx, and we
Correct.
apply the limit. It becomes 0 by 0 form.
Yes,
Is this correct?
yes, you are correct. Okay.
Yes, sir.
So basically, if you take now cos x times sine 4x. Sorry. Now this limit, so you take this to be as f of x and this to be up as g of x. Okay, so then as you can see now, this is in 0 by 0 form. Okay, so now you apply L'Hospital.
Oh, so we have to just take the differentiation of the f of
Yeah.
x.
So
right?
again, like, see, the thing is, this is correct, but again, like, if you ask me, then certainly I will not do in this way. I can see some, you have to differentiate it. It's not difficult again, like, but you can probably, I feel like you can do it slightly easier way. So
Sir, we can also do 2 sine 2x cos 2x like this
exactly,
way.
yeah. So
Then we
now,
again divided into 2 sine x cos x.
yes, correct. So now you take cos x.
Hmm.
They're basically the same thing, right? This, whatever I have written above and this
Yes.
expression, they're same,
Yes,
right? So this limit is what? If you split it, okay, this limit is what? 1, right?
Yes,
This
sir.
limit is 1. And what is this limit?
Uh, uh, it will give 4 into 1 and 4.
Yes. Right?
Okay. So we are just splitting the terms, then we will get the
Yeah,
answer.
you can do in this way, and someone already said, right? You can take it, this whole
fx, the
yeah,
cos
whole-
x into sine 4x.
yes, hold this expression as your f of x. But then again, you have to apply L'Hopital rule properly. Okay, you have to take the derivative. To differentiate that, you have to apply this product rule.
Okay, sir.
Sir,
Sir,
can I ask one thing?
Please.
Sir, actually, day before yesterday, there was a class on activity and practice session by TAs, from where we can get the link, because it was recorded, I guess. From where we will get the link so that I can watch it again.
Yeah, it was.
It was recorded, right? You are
Yes,
saying?
sir.
I am
Yes,
posting
sir.
that link in chat. You can visit.
Okay.
Okay, sure, sir. Please send it so that I can get benefit from it. Okay, thank you.
Okay, so now this is fine. How you can compute this?
Yes, sir.
Okay, any other questions?
So what is the difference between differentiation and derivative?
Sorry?
Sir, there is a concept like differentiability, and then it is like derivatives. What is the difference?
They are
Or
basically the same thing.
Okay.
You basically, yeah, so you just use them slightly different. A function is differentiable, but the derivative of the function is this. So this is this, but mathematically they sort of represent the same.
Okay, sir.
Any other questions?
Sir, have you sent the link in the chat?
Yes, you can see in the chat
But
box. I guess
yeah,
Saad.
I have seen that,
Hmm.
but this is not the
Sir,
video
I
that
have
I
sent
am talking
from
about.
Google Calendar.
So the session was held by the TAs, I guess, the instructor, those who used to
17,
come in
18,
office
19 को
session,
दो है थोड़ा को डेढ़ दिए फिर
and they solved that in series.
Mhm.
The assignment question. Can you please share that link? All the assignment questions were solved in the series in that video.
Okay, I'll check with that. Certainly, currently I don't have. I will share with you if it was recorded, then probably will share with you.
Sir, I am sharing my email ID in the chat box. If you, whenever you will get, you can share it to me.
Yes, sure.
Okay. Thank
Yes, sir. In Google Calendar, that Gmeet is recorded and it is viewing at, like, you can see the video, but when we click the video, it is saying access is denied.
Okay, I'll check with that. Okay, don't worry. Just let me. Any other question from week 8?
Sir, one question, general question is, when I watched some of the solutions, when they apply the L'Hopital's rules, still it comes in an indeterminate form. Then they are reapplying the L'Hopital rules again until they get it in a form which is which is not an indeterminate form. So that is how we should do it. When we apply L'Hopital rule, if it is coming in indeterminate, we again have to.
Yeah, you can apply L'Hopital rule multiple times. Okay, no problem. So if you are again getting some indeterminate form, okay, you can again apply the L'Hopital rule, right? By again the L'Hopital rule, the original limit and whatever you are getting multiple times, the limit of the. So suppose you have right. So suppose this is 0 by 0, right? So if you apply L'Hopital rule, okay, then what you have to do? You have to take this one, right? So
yes.
Again, if this is in 0 by 0 form, okay, again to compute this limit, you can again apply L'Hopital.
Okay.
So this limit is same as this limit. And this limit is same as this limit. So it doesn't matter. You can apply L'Hopital rule. Again, of course, you can apply if this is in indeterminate form. Okay. You can apply n number of times. No issue.
Okay, thank you.
Yes.
Sir, I have a doubt in tutorial 7. The equation is limit x tends to 0. E to the power minus 1 by x square.
E to the power minus 1 by x square.
In the whole divide, x square.
X square, yeah.
Yeah, from here, ma'am is applying the L'Hopital's rule. So I didn't cope up with ma'am how she differentiate or do the next process. Can you please explain this one?
So first tell me why she's applying this L'Hopital rule?
Because if we put 0, like it is minus 1 by x square, no?
This is 0, right?
It will be 0. And if we apply in the above section, it will also be 0.
You are saying e power minus x square, correct? So e power, if I take this function, e power minus 1 by x square, then if I'm going towards 0 from the left hand side, I'll get positive, then e to the minus infinity. So again, this will give me 0. If I'm coming to 0 from the right hand side, the same thing will happen. So this is 0 by 0 form. Yeah, correct.
Yes, sir.
Yeah, so now you need to apply the L'Hospital rule, right?
Right, sir.
Yeah, so if I apply this L'Hospital rule, then what I will get? So this is same as limit x tends to 0. So if I differentiate this, what I will get?
E to the power x is same minus 1 by x square, and from here, what I thinking?
2x cube.
Yeah, the 2x cube. I didn't understand how we get the 2x cube, 2 divided by x cube.
So what you are actually doing? You are differentiating this, right?
D by dx. Right, sir.
See what now actually here you are applying the chain rule, right? What is this?
Derivative of f of fx.
No. What is this function? This is composition of two function, right? Okay, I'm getting some noise from other I guess office, not from me, obvious. Yeah. So yeah, so what is this? This is actually e power x, okay, composite with, right?
Okay.
This is f compose g, right?
Right, sir.
So now you can apply the that chain rule, right? For composite function, you apply the chain rule, right? So
right, sir.
So what is yeah? So what is the what is the derivative of f of gx?
It is f derivative the same gx,
right,
into g derivative x.
Correct. Right. So
right, sir.
So what now? My f is f of x, correct?
Right, sir.
And g of x is 1 minus 1 by x square, right? So if I differentiate it, I will apply the same rule. So what is, so f is what? F of x is ex, right?
Right, sir.
So what is this? And g of x is minus 1 by x square. So first what I will do, so the derivative is f dash of gx.
Yes, sir.
And derivative of e of x is e of x, right? So I just need to substitute g of x. This is e power 1 by x square.
X square.
This part, right?
Right, sir.
Then I need to differentiate this g of x. Okay, if I differentiate this one, then what I will get? Minus 2 plus 2 minus minus, it will get, this is 2 by x cube. Correct?
So this is what I am not getting, right? The derivative of gx.
What is this g of x? This is
minus 1 by x square. Okay, minus x. Okay.
Then if you derivative it, what you will get?
We can it will be n into x n minus 1.
Minus 2 times x power minus 2 minus 1.
Okay.
Right?
Right, sir.
So this is what?
Minus 2 x
times x to the power minus 3.
Minus 3. Okay.
This is 2 times x power cube.
Okay, sir. This is the confusion. Now I will understand the question, sir. Thank you.
Okay, fine. Okay.
Sir, one basic query in this. Can you scroll up a bit?
Yes.
Sir, you have written 0 by 0 form. Can you explain once more, like the numerator part only?
Yeah, so this part is more or less easy, right? This is 0 by 0 form, right?
Yeah, but how the numerator part is 0.
Yeah, let me explain. See, what you have, e power 1 by x square, right? Minus 1 by x square. This x square is actually important. Okay, so if you put 1 simply minus 1 by x, then you can't apply. Okay, because the limit doesn't exist. So we want to know. What is this value, right? X tends to 0, e power, correct? So
Correct.
for that, first what we have to do, we have to find the left hand limit, right?
Yes, sir.
So
Yes, sir.
left hand limit means what? I have 0 here
Yeah, 0 negative.
And we are coming from
and
left side.
x is coming from this side, and of course, since we are coming from the left side, that means x is negative, right?
Right, sir.
So
Yes, sir.
so if x is negative and as well as small, right? Then what about 1 by x square? If x is going towards this side, towards 0, and of course since x is going towards 0, that means x is very small, right?
Yes, sir.
So
Right,
if x is going towards 0 from the left hand side, then where this 1 by x square will go?
Closer to 0.
Closer to 0.
Infinity.
Think
Minus
twice. Okay, see,
Minus infinity.
Infinite.
Infinity, sir.
infinity. See, x is negative, right? X square is positive, right?
Yes, sir.
So that means 1 by x square. See, x is negative and small, very small, right?
Right, sir.
That means x square is positive and very small, right?
Yes, sir.
That means 1 by x square is positive and very large. Correct? That means this will go towards plus infinity, right?
Okay. Okay,
Okay,
sir.
sir.
That means minus 1 by x square will go towards
Minus infinity.
minus infinity. Correct. So so that means e power minus 1 by x square will go towards 0, right? So that is what we wanted to compute, right? When x is going towards for left hand limit, when x is going towards 0 from the left hand side, where this thing is going, right? And as you can see, this is going towards 0, right? Correct or not?
Yes, sir.
Yes, sir.
So the
Yes.
left hand limit, here the left hand limit is 0, right? So the next thing is right hand limit. So for the right hand limit, what we have 0 here, and we are coming from the right hand side, right? X is coming from the right hand side. So if x is coming from the right hand side, where 1 by x square will go?
Plus infinity.
Correct, plus infinity.
Plus infinity, right, sir.
Then 1 by x minus 1 by x square will go towards minus infinity.
Minus
And
infinity.
e power 1 by x square will go
Goes to
towards
0.
right? So as you can see, the left hand limit and the right hand limit, they matches, right? So that means it has a limit, and the limit is precisely 0. Okay, and that's why this whole thing is in 0 by 0. Now is it clear?
Yes, sir.
Yes, sir.
Okay, whoever asked this question, is it
Yes,
clear
sir.
to you?
Yes, sir.
Yes, sir.
It is clear. I was putting 0 instead of x and then getting infinity and getting confused. Okay, now it's clear, sir.
Okay, fine. Yeah, Suman.
Yes, sir. So I have a doubt with the one. It is this solve with us 8. Solve with us not graded thing, and the question number is 5. Question number 5. Option 4 is correct. Is what the answer says. But see, the last step before where they arrive, it is equal to e power x into 1, where it is ideally they say it is e power x, but the previous step where they apply limit h is equal to 0, which is e power h minus 1 by h.
Just a minute.
Yeah.
So
number
you have
5.
problem with the last option, right?
Last option, yeah.
So you are saying the last option is incorrect or correct?
Yeah, I thought it is incorrect, but the solution says it is correct.
So
if
why you think it is incorrect?
Because if you see that, you know, the third step before the in the second line, the first step, second line, first step. Yeah, this one. E power, where they apply h is equal to h tends to 0. E power, so e power h, e power 0 will be 1, right? So 1 minus 1 will become 0.
0.
By 0. So, but why they have kept it as 1?
Because the limit is 1. You apply L'Hospital rule there. This is 0 by 0 form, right?
Yes, correct.
Now you apply the L'Hospital rule. What will be the limit?
So if I apply e power h will remain as e power h. Minus 1 will go off. Oh, okay, okay, then it will become 1 by
You try to apply L'Hospital rule, you'll get the answer. Yeah.
Okay.
To compute the limit, this is in 0 by 0 form. You now next thing is, so you are asking why this they have written 1 in place of this limit, right? You apply the L'Hospital rule, then you will get 1.
Okay, so it got it. Okay, fine. So so we can do derivatives for numerator and denominator separately, right?
Yes,
or
that is how you do that is how you apply L'Hospital rule, right?
Yeah, so in this case it will become e power h in the numerator, because 1 will go off, and denominator h will become 1.
Yes.
So 1 by 1. Okay. Yeah. Okay, got it. Yeah. I have one more doubt. That is in practice. Yeah, it is in activity 4.8 activity questions.
4.8.
Sorry, 8.4. Sorry, sir. 8.4. 8.4 activity question number 7. So there, my answer was 5, but the answer provided is 2.1. So I probably I can share my screen how I computed.
No, but just tell me what is the equation of the tangent at 4?
The equation of tangent at 4 is, yeah, for me it is 1 by 4 into x minus 4 plus square root of 4.
1 by 4
into x minus 4 plus square root of 4. That is
1 by 4 times x minus 4 again.
Plus square root of 4.
Then equals to?
Yeah, that I simplified and came as 20 by 4 when I substituted 16.
This is equals to y, right?
That is equal to y, yes.
So then, so y equal to, if you have done it correctly, I certainly I don't know. I have to that I have to. This is 2, right?
That will become 2, yes.
So you want to approximate the value of 4.4. Now, if you apply 4.4 over here, right? So what I will get? 1 by 4 times.
Oh, that is okay. That is 4.4, is it? Sorry.
Yeah.
Okay, I thought it was 4 into 4. Okay, yeah, if I apply 4.4, then it gives.
Any other question you have?
Yes, one more probably. Yeah, I will ask again, sir, for others to have.
Yeah. Daras Pratap Singh.
Yes, sir. I have a doubt in activity question 8.3. And question number 10.
Just a minute. Question number 10 I have already discussed. Yeah, you can check.
Okay, sir. And question number 7 also.
7, and you can check the last session video. I have already discussed this question number 7. This Friday session I have discussed this question number 7.
Friday session.
Yeah.
Okay, sir.
Hmm.
Sir, actually, Friday sessions video is not available. Okay, in activity practice session. Okay, sir, got it. Okay. And in activity 8.2.
8.2.
8.2, question number 3. Question number 3. Right. Yes, sir. Sir, I don't get it.
Yeah, that fine. But what you have tried, can you tell me?
Yes, sir. Sir, I have tried that if a function is differentiable, then we can draw a tangent there. And in floor function and ceiling function, I don't see that we can draw any tangent at point. So I think it is not differentiable at any point.
If x equal to greater than equal to 0, right? If x
Yes,
is
sir.
less than 0, right?
Yes, sir.
And mostly it's basically, yeah, it's in between minus 1 to 1. Okay, so now tell me what will be the graph of this function?
Okay. So,
tell me how I can draw the graph.
Yes, sir. It will be from origin to 1, and at 1 it is open and closed at origin, and then similarly step up when from
This is
1
0, 1,
close
right?
1.
This
Yes,
is
sir.
what you are saying.
And then 1.
And then?
And then from 1 to 2. From upside. Yes, sir. And open
And
at
at
2.
2, this is 2, right?
Yes, sir.
And this is at 1. Okay. So 2, this is 2. And at 1, this is 1, right? And what about the left hand side?
Left hand side, sir, it will be close at 0. No, it will be open at 0 and close at -1.
This is what? This is smallest integer function, right?
Yes, sir. It will be, sir, close at -1 and open at 0. And no. I think
so. It will be, I guess, it will be like this. Okay. So this is at 0. Of course, this is 0. Okay. And again, this will be like this. Okay. This is -1. This is -2. Right. And yeah,
right.
This part is included. And this part is also included. Okay. So the only problem, as you can see, is the integer point, right? So here,
Yes,
the limit, as you can see, at this point, limit doesn't exist, right?
Yeah.
At this point, limit doesn't exist, right? So,
right.
So why you think in between these points also limit will not exist? The function is not differentiable. This is so in
Sir,
this
it will be differentiable in this interval. Yeah.
Yeah, so in this interval, okay, not, of course, I'm excluding the endpoints, okay. So in this interval, this is a constant function, right?
Right.
So if it is a constant function, then this is differentiable in the interval. In basically
Yes.
yeah.
Yes, sir.
So then what is your problem?
But sir, the answer is showing that it is also differentiable at x equal to 0.
X equal to 0.
Yes, sir.
Just a minute. Either the answer is wrong, or of course, otherwise we are making a mistake.
Sir, at 0 to -1, the graph is not y equal to -1.
Just a minute. Just a minute. Let me. F is differentiable at x equal to 0. Then probably we're just a minute.
One graph.
So this is the greatest integer function, right?
Yes, sir.
Yes, sir.
So if it is the greatest integer, then this graph is fine, correct?
But
Correct?
yes, sir.
Yes, sir.
The only
Yes, sir.
problem is this smallest integer function, right? So
Yes.
what is the definition of smallest integer function? What is the definition of smallest integer function?
The value will be 1 plus the integer value of
A will be a plus 1 if
It will
is
a plus 1. If
if-
x belongs to a plus 1.
right.
No, I'm asking the definition of smallest integer. I have said it multiple times in the same in our session. So this is the smallest integer greater than or equal to x, right? Yeah, so we have made a mistake while drawing the graph. So then what is the smallest integer of 0.4 minus 0.4?
It will be 0.
It will be
It will be 0, right? So in this interval, this is actually 0. Okay.
Yes, sir.
So that means so in this interval, as you can see, okay, this is precisely this line, right? So then in that case, this is differentiable at 0, right? So then after that, the jump will come here. Okay. So the advantage of taking this in one side greatest integer and one side smallest integer, that you have this small line segment connecting this -1 and 1. Okay, so that's why this since this is just a line segment, and as you can see at 0, the left hand limit is 0, right? The right hand limit is 0. So the limit also exists, and you can check that this is also differentiable because this is just a line segment, right? This is if you consider this function, this is precisely constant function, right? Constant on -1 to 1, right? So that means this is differentiable on this interval, right? So that means this is differentiable at x equal to 0 as well. Clear now?
Yes, yes.
Okay, fine. Yeah, Rajiv Kumar, you have any doubt?
Yeah, I have doubt regarding continuity.
What is your doubt?
How when function is differentiable, then it implies continuous.
Correct. Correct.
Sir, in
Then
adding
I'm-
that,
I'm
how
not
to
getting
find?
that part.
Just a
Sir?
minute. Let him talk. Okay. So whoever asked this question first, let him talk. Yes.
I'm not getting how function is, if function is differentiable, then it must be continuous.
Yeah, this is true. You want, so what you are asking, the proof.
Yeah, I'm asking what.
So what is the definition of differentiability? Tell me first.
If limit h tends to 0, f of a plus h minus f of a exist. A plus h minus f of a by h. If exist, then it must be differentiable.
Where? Then it is differentiable? Correct.
At a.
Correct. Absolutely. Then f is differentiable at a, right?
Yeah.
So yeah, so to show that this limit, actually the function is continuous. Okay, so one of the equivalent condition that f is continuous at a, f is continuous at a if limit s tends to 0, f of a plus s is same as f of a, right? This is what you want to show, right? So in particular, what we need to show, zero, right?
Yeah.
So you know that f is differentiable, right?
Yeah.
That means this is this has a value, right?
Yes.
So now what you do? You take this one, limit s tends to 0, f of a plus s minus f of a. You want to compute this. Now what you do? You try to divide by s and you try to multiply by s, right?
Okay.
So if you do that, then what you will get? Limit x tends to 0, this, whatever this is, times limit s tends to 0, h. So this is, this is the derivative, right? Derivative of the function. It has a value, right? This is f dash a.
Yeah.
And what is this value? This is 0, right?
Yeah.
So this is 0. So in particular, what you are getting? This to be 0, right?
Yeah.
That means the function is continuous.
Okay. There is other way to show that this is differentiable than continuous.
Sorry?
There is other way to show this same thing.
Some different proof you are asking.
Yeah.
Yeah, might be. Yeah.
Okay.
But what is the problem with this proof?
No, I'm getting right.
Okay.
Okay. Thank you, sir.
Yes. Prabidya.
So yes, sir. So 8.3, fourth question, sir.
8.3, fourth question.
Yes, sir. Sir, in this, I should first start off with L'Hopital's rule, sir. I should check whether it is of the indeterminate form, and then there is this f of x minus f of 1. So should I just directly do it, substitute and differentiate it?
Yes, that is the way. So if you see f of x minus f of 1 and divided by x minus 1. So as you can see, this is 0 by 0 form, right?
Yes, sir.
Now you simply apply the L'Hopital rule. You divide the function in the numerator as well as divide the function in the denominator.
So for the denominator, when I differentiate, I'll get 1, no, sir?
Yes, yes, yes.
And for the numerator, the first term will be 9 minus x square, the whole power 1 by 2. And
okay,
then
so you have what? What is your function?
f of x is equal to root of 9 minus x square.
9 minus x square. So in the numerator, basically you will get f dash of x, right?
Yes, sir.
So what is f dash of x? This is half.
Sorry, sir. 1 second, sir. Minus 1 by 2, power minus 1 by 2.
Correct. Right?
So that minus 2x is, I didn't get that part.
Same thing. See, just now, see, you are not applying this rule. So I don't know whether you were here. So when I explained this derivative of this function. Okay.
Oh, yes, sir. Yes, sir.
So
it's
so
u dash dot u. Okay.
Yeah.
Sir.
So again, the same thing. See, this is a two. This is not a single function, right? This is a composition of two functions, right? So one, you have f of x is square root of x, right? And
Yes,
another one is g of x, which is 9 minus x square, right? And you have this thing, right?
Yes, sir.
So you have f composed of x, right?
Yes,
So,
sir.
so if you apply the rule, what you should get? F dash of g of x.
G of x dot g dash of x.
G dash of x. Okay.
Yes,
so
sir.
this thing, whatever you are getting, okay, only because
Yes,
of
sir.
this one.
Yes,
right?
sir. This
So
part
you-
I got, sir.
Yeah. So you have to apply this. You have to also take the g dash of x, right? So if you take g dash of x, what you will get? Minus 2.
2x square. Yes, sir. Correct, sir. So then there is this minus of f of 1. So what should I do with that, sir, actually?
So that is a constant, right?
Yes. Okay, sir. Yeah.
That is a constant. This is a constant value, right? So if you take the derivative, it will give you 0, right?
0. Yes,
Yeah.
sir.
So this will certainly will not come in the expression if you take the derivative, right? You have only f of x minus f of 1, right? So
Yes,
this
sir.
is a constant. So this will give you 0. So if you take the whole
Only that.
differentiation, then you will precisely get f dash of x.
Yes, sir. Okay. So one more doubt, sir. Like the same activity, but question 9, sir. If f is an even differentiable function, then f dash is an odd function. So can you just give me an example, sir? Like I was not able to understand that.
Okay, so okay, giving example is easy. Okay, so that is, you just have to take, because this is true for all. If f is, which one you are saying, option 3 or 4?
So both are correct. 3 and 4 are correct.
Yeah. So suppose if you take, this is correct, right? So if you pick any even function, okay, this is true. So suppose you have a even function, right? What is the definition of even function? I'll come to the example. So just before that,
power is positive and it will start and end, like the end behavior will be on the same side of the axis. Like if it starts in the negative y, it will end in the negative y. The highest power is 2 or multiples of 2.
this is the definition of even.
Yes, sir, correct, sir.
I don't know, like but you said something different. Okay, it's
Yes,
even
sir.
not close to this one. I don't know what you wanted to say. Okay, so this is the definition of even function. F of minus x, x is equals to f of x, right?
Yes,
that is the definition of even function. So
Yes.
so if I so what I want to know if I have a function a which satisfies this property. Okay,
Yes, sir.
I want to know about this f dash of x, right? I want to know whether this f dash, so okay, so this is the condition for even and odd function. What is the condition for odd function? F of minus
F
x
of minus x equal to minus x.
minus of f of x, right?
Yes, sir.
This is the odd function. Okay.
Yes, sir.
So if I have an even function, I want to know about f dash of x. Okay, whether this is a even or odd, right?
Yes, sir.
So now you take the derivative of this, whatever is there, you take the derivative. What if you take the derivative of this left hand side, what you will get?
F dash of minus x, I guess.
Minus x again.
I don't know, sir.
Again, same, you are making the same mistake that you have done here. See, so the thing is, okay, so what you have to do? See, here you don't have an identity function, you have a minus, right?
Yes, sir.
So what you have to do? F dash of g of x again times g dash of x, right?
Yes,
you have to
okay.
differentiate that function as well, right? See,
Yes, sir. Yes, sir.
if I have f of x, okay,
Yes, sir.
and here my g of x is x, right? And that's why I don't differentiate gx separately, because if I differentiate, then I will get 1, right?
Yes, sir.
So that's
Yes,
why
sir.
I don't separately differentiate x, because if I differentiate x, then I will get 1. There is no point of doing that. But here I don't have x, I have minus x. If I differentiate it, I will get a minus 1, right?
Yes, sir.
And this side I will get f dash of x, right?
Yes, sir.
So now what I'm getting, f dash of minus x is same as minus of f dash x, right?
Yes, sir.
So what is the condition? So which condition this f dash of x is satisfying?
The odd function.
This precisely satisfying this condition, right?
Yes, sir.
So this is a odd function.
Okay. Okay.
So the derivative of even function
Will
is
be the
odd
reverse
function.
of-
Odd
Yes,
function,
sir.
right?
Yes, sir.
And similarly, you can see that the derivative of odd function is even.
Yes, sir.
That you can do, but okay, before that, let me, okay, you can try this part. Okay, see this odd part. Okay, so you ask about example. You take, for example, you take this function f of x equal to the simplest one, f of x equal to x square, right?
You get 2x.
This is a even function,
Yes, sir.
right? So if you differentiate this, what you will get? 2 of x.
Yes, sir.
But what is 2 of x? 2, so 2.
It's an odd function.
Right. So if I substitute f dash of minus x, right?
Yes,
what
sir.
I will get? 2 times
Minus 2x.
minus x, which is minus of 2x, right?
2x.
And this
Yes,
is
sir.
precisely minus of f dash of x, right?
Correct. Yes, sir.
So this is a odd function. So this is again, this is true for any arbitrary even function. Instead of x square, if you take any even function, it has to satisfy the condition, because we have just now we have 2t. Okay.
Yes. Yes, sir. Okay. Got it. Thank you, sir.
Thanks. Okay, so again, like I just want to discuss few things. Okay, that is what I have planned for this session. Just give me a minute. I have wrote something. Yeah. So yeah. So. Okay. Okay, so I guess all of you know. So first tell me, when you say that a function is differentiable at a point A, when I say that f is differentiable at x equal to a.
If it has a unique tangent.
So that is a different definition. I'm asking about the formal, the main definition, when I can say that f is differentiable at x equal to.
Limit h to 0 f of a plus h plus f of a divided by h exists.
Right? This exists, right? Correct. So if this limit exists, then you say that whatever this limit, that is basically the derivative of the function Rt, and if the limit exists, you basically say your function is differentiable at Rx equal to a. So before going into that, so how you compute this derivative? You compute by taking the left hand limit, right? You compute the left hand limit, you compute the right hand limit, right? So when you take left hand limit, so that basically means you are you are taking s towards 0 negative, right? This is what you do when you compute the left hand derivative, right? So left hand limit, or for in this case left hand derivative, okay, and this is your right hand derivative. And when you compute right hand derivative, what is this? This you take s tends to 0 plus, right? You come to for here you come to 0 from the right hand side of 0, and here you come to 0 from the left hand side of 0, right? So okay, that is what you do. So before that, okay, so next you tell you what is this expression, what basically this thing represent.
Which thing, sir?
This one.
Derivative of function at a.
No, you forget about this one.
Okay.
Rate of change, sir.
You forget about this this rate part, whatever I have written in the rate.
Change in A, I think.
Okay. So okay, so more or less some of you are like, this is not change in A, okay, so sort of change in A with respect to change in Y with respect to change in X, okay. So but okay, I wanted some different answer. So what you are doing, so you suppose this is the graph of your function, okay, let's say okay, this is the graph of your function, and let's say this is your A, right? And if this is A, then this point is what? This point is what? What is this point?
Critical point.
A comma fx, f of a.
A comma f of. And suppose your h is some positive number. Let's say your h is positive number, and if I take a plus h, I'll reach somewhere here, right? A plus h. So if this is a plus h, so suppose this is a plus h, then what is this point? This point?
This is a plus h, comma f of a plus h.
F of a plus
h,
right?
Right, sir.
Now, if I join this line, if I join this line, what is the slope of this line?
F of a plus h minus f of a divided by a plus h minus a.
F of a plus h minus f of a.
Yeah.
Divided by a plus h minus a.
Minus a.
A plus h minus
a.
Yeah. So if I write it properly, then what I will get? F of a plus minus a, f of a by h, right?
Right, sir.
So this is what I have written here, right? This is what I have written here, right? Or
yes. Right, sir.
So this expression, whatever I have written in black, so this precisely represent the slope of this line, right?
Yeah.
So slope of this line. So with respect to some h, right? So if I reduce my edge slightly, okay, so if I reduce my edge slightly, so suppose this is, then I will get a point somewhere here, right? So
Right, sir.
so instead of here, I will get some point here, right? And then I will get some different line, right? Instead of this line, I'll get this line, right? And here I will get the slope of this line, right?
Right, sir.
And so again, if I reduce, I will get a even some slightly different line. Okay, so and again, if I reduce, and I will get some new line. So if I take my edge, so if I take my edge towards A, right? So
Right.
what actually I am doing? I am actually taking the slope of this line, right? Slope of this line, and I'm taking the limit of the slope of this line, right? First I have this line, then I have a smaller line, then I have not smaller, some point which is closer to this A.
Closer
Okay.
to A.
Again, I have one more line. Again, I have more line. So when I'm taking limit h tends to 0 of this thing, okay. So in particular, I'm taking the limit of the slope of this line, right?
Limit of the slope of the
Slope
line.
of this line, right? This is the slope of a line, right? This is the
Okay.
slope of a line, right? This whole thing, the numerator by the denominator. This is the slope of a line, right? This line.
Slope of a line which is changes when it come closer to A.
Yeah. So when I'm taking this s closer and closer to 0, that means I'm taking the limit. So for example, let's say if you take s equal to 1, right? You will get a line, right?
Yes, sir.
You will get a line connecting
A and A plus 1.
A f of a and a plus
A
1,
plus 1, comma f of A plus 1.
right? Again, if I take some, so then if I take instead of 1, if I take 1 by 2, a plus 1 by 2, right? So then I will get some different line, right?
Yes, sir.
Of course, it will passes through this point, but again, it will pass some a plus half,
Comma f of A plus half.
plus half, right? And similarly,
Right,
I can take 1 by 3, 1 by 4, 1 by 5. So in particular, what I am doing, so in this process, I'm taking s to be 0, right?
Right, sir.
And whatever, and what I'm getting here, I'm getting the slope of the line which connects a plus s minus a comma f of a and a plus s,
comma f of A plus h.
right? So I'm taking the limit. Okay. So what actually it's basically what it's doing, it's basically giving you, so if I have a point like this and I'm computing the derivative at this point, okay, so I have a tangent line, right, at this point.
Right, sir.
So when I'm taking the limit, okay, so I have a tangent line, okay, a plus s, then I have one more, okay, my bad, made mistake again. So first I have this line. This is not tangent line. This is a secant.
Yes, sir.
A plus s. Then if I reduce it, then I will get one more line. Okay. Then if I reduce this little further, then I'm getting one more line. Okay. And what I am actually doing, I am actually going closer and closer to this original tangent line, right?
Right, sir.
And what I'm computing here, I'm not computing the equation of the line. What I'm computing, instead of computing the equation of the line, this expression is giving me the slope of this line, right? It's giving me the slope of this line. Okay.
Yeah.
So that means when I'm taking limit h tends to 0, actually what I'm getting, so this limit is actually going closer and closer to the slope of this tangent line, right?
Okay.
If I am doing from the right hand side, okay, the same thing I can do from the
Left
left
hand
hand side as well. Okay. So that is what actually we are doing in case of derivative. Okay. So when you are doing it from the left hand side, actually you are taking this line, secant line, and you are computing the slope. And when you are taking this h towards 0, okay, this line is coming closer and closer to this
slope of the tangent line.
Okay. So what is the problem actually when when the function is not differentiable? For example, to consider this
floor function.
Not floor function. This is, I don't want to go to this floor function.
Okay.
You take the modulus function.
Okay.
That is the easier one to deal with. Okay. Right. So you take this modulus function.
Yeah, right.
So this is 0, right?
Yes, sir.
So if I take some 0 plus h, right? If I take some 0 plus h, then what actually I am doing? This is 0 plus h, f of 0 plus h, right?
Right, sir.
And this is 0 comma f of 0, right?
Yeah.
Yes, sir.
So if I am coming from if I'm taking my h towards 0, okay, if I draw the line, I'll always get this line, right?
Yes, sir.
Yes. And what is the slope of this line?
F of 0 plus h minus.
This is 1, right?
Yes, sir.
This is y equal to x line, right?
Yeah.
So it doesn't matter what h I am choosing. So if I am choosing h some 1/2, okay. So sorry, if I am choosing my h to be 1, still I am this line. If I'll choose my h to be half, still I am this line. So it doesn't matter what h I'm taking from the right hand side, I'll always be in this line. Okay.
Yes.
So that's why when I'm taking the right hand derivative, my right hand derivative is always 1. Right?
Yes, sir.
But if you do the same thing on the left hand side, okay, this is 0 plus let's say 0 minus 1. Okay. So then what you will get? You will get this point, right? So in that case, your tangent line is this. And what is the slope of this line?
Minus 1.
Again, if you keep coming closer and closer to this, you will get the same line, right? You will get the same line, and the slope of the line is minus 1. So that's why your right hand limit is minus 1. Okay. And so when you are coming to the right hand side, when you are coming from the right hand side, this is your tangent. This is your tangent. Okay. When you are coming from the right hand side, and when you are coming from the left hand side, this is your tangent. Okay. So that's why you have two different tangent. Okay. And one case, the slope of this tangent is 1, and here the slope of this tangent is minus 1. So that's why you don't have a unique tangent. Okay. And that's why this function is not differentiable at 0. Okay. So now is it clear what really we are doing in the case of differentiability?
Yes, sir.
Yes.
Okay. So let me show you something in GeoAlgebra.
So these both lines have their own tangent, different tangents.
Different tangent, and that's why you basically, so when you have multiple tangent, in that case you say that actually tangent doesn't exist.
Okay, okay, sir.
Okay. So you say tangent exists when you have only unique tangent. Okay.
Okay, sir.
Just a minute. Let me share my screen. You can see this part, right?
Yes, sir.
Okay, so this is a function, right? G of x. Okay, so before coming to this thing, let me write it down. Okay, what is your function? Your function is 1 by x. Right? This is your function. Let's say this is your function.
Okay.
So, so first tell me, whether this function has a limit at x equal to 0.
No, sir.
No, right?
Yeah.
The left hand limit is what? The left hand limit is 1.
Yeah.
And the right hand limit?
0.
0, correct. So this function is not continuous, right?
Yeah.
And as well as not
Differentiable.
Differentiable. But if I compute the left hand derivative, suppose if I compute the left hand derivative, what is the left hand derivative?
1.
1, right? And what is the right hand derivative?
2x.
At 0, I'm asking.
It's
So,
0.
0, right? The right hand derivative, see, right hand derivative means what? You are coming to 0 from the right hand side, right? Your x is positive. In that case, you have x square. If I compute, I will get 2x, right? And at x equal to 0, this value is 0. Okay. So, so one thing is clear, this function is neither continuous nor differentiable. And here the left hand derivative is 1, right? And the right hand derivative is 0, right? Okay, now let's go back to the graph. So, as you can see, so you can see this graph, right?
Yeah.
Yes, sir. Yeah. So as you can see, when this D is approaching towards A from the right hand side, right? As you can see, the value of the function is going towards 0. Right? So that's why my left hand limit, right hand limit is what? 0. Right? So, and when this D is approaching towards A from the left hand side, as you can see, the value of the function is approaching towards -1. Sorry, 1, right?
Yeah.
So that's why the left hand limit is 1. Now, if I consider the derivative, so as you can see, I'm now taking the derivative, right? So this point is what? This, as you can see, what is this point? What is this point B?
H comma GH.
GH. What actually I am doing? So just a minute. You can see my writing pad, right?
Yeah.
Yes, sir.
So what I'm trying to do here, I'm computing the derivative, right? At x equal to 0, right? So so if I compute that, then what I will get? Limit s tends to 0, 0 plus s
minus f of 0.
Minus f of 0.
0
divided by h.
By h, right? And this is precisely what? Limit s tends to 0, f of h
divided by h minus
f of 0
divided by h.
By h, right? So this is precisely, as you can see, this is this thing, this part, whatever I have, this square bracket, sorry, inside this square. Okay, this expression, this is precisely the slope of the line. If you go back and see this line, okay, the slope of the line connecting A and B, right?
Yeah.
Right, sir.
Correct or no?
Yes, sir.
The thing is, yeah. So when I'll when actually I'm taking so when I'm taking my I made a what is the B? Yeah. So as you can see, when this B is coming closer and closer to A, right? That means my AH is
So there is a play button. You can click on that.
Yeah, but it will go fast. So as you can see, when this B is coming closer and closer to A, the derivative, the slope of the line actually is coming closer and closer to 0, right?
Right, sir.
So that's why I did not want to play it. Okay. So if you see this, when you are taking this B closer and closer to this point A, right? Your slope of the line is what? Going closer and closer to 0, right?
Yes, sir.
So what basically you mean? What basically you mean that I'm taking B closer and closer to A? That means I'm taking A towards 0, positive, right? And I'm getting this slope of this line is basically going towards 0. That means my right hand derivative is 0. And same thing if I do, if as now you can see I'm taking this B closer and closer to A from the left hand side. Right? And in that case, where this slope is going? Any idea?
Coming close to 1.
Yes.
Sir, if you click on the play button, there is also a speed control above. You can slow down from.
No, I don't think okay, just a minute. Yeah. So yeah, you can see when you are coming from the left, the slope is going towards 0. And when when you are coming from the right, the slope is going towards 0. And when you are coming from the left, the slope is
moving towards 1.
Yes.
Okay, sir, it's clear now.
Yeah. So yeah, so that is what actually I wanted. I created some other thing as well. Okay, so I guess this should be enough. Like what is at least what is going on in derivative.
Yes, sir.
Okay. Any other doubt from your side?
Like, sir, you calculate the left hand limit or the right hand limit very fastly. Can you give some tips in this, like g of x is equal to 1 plus x? You just say it is left hand limit is 1.
No, see, this is left hand limit again. That is what I said, right? Left hand limit means what? You are
coming from the left side.
Not limit, left hand derivative you are asking, or
no, calculating the left hand limit. If we are coming from the left side, you say left hand limit is 1 and right hand limit is 0.
See, left hand limit means what? You are coming to 0 from the left hand side. That means x is negative, right? If x is negative, what is the value of the function? 1 by x, right? Right or not?
Right, sir.
Yes, sir.
So then where 1 by x will go if x is going towards 0? it will go towards 1, right?
Okay, sir. Okay.
So that's why the left hand limit is 1.
Okay, sir.
And when you are coming to 0 from the right hand side, what is the value of the function? X square, right?
X square.
X square.
So where x will go, x square will go if x is going towards 0.
0.
So this is right hand limit. Similarly, if you compute the left hand derivative, okay, so same thing. You have 1 by x, right? So if you differentiate 1 by x, what you will get?
1.
1. So that's why this is your left hand derivative.
Okay, sir.
So
okay,
if you
sir.
differentiate x square, what you will get? 2x.
I think 2x.
What is the value of 2x at 0?
0.
So this is your right hand derivative.
Okay, sir.
So as you can see, you are getting one, so left hand derivative and right hand derivative, they are not equal, right? So that's why this function is even not differentiable. You don't have to do that. It's from here itself, you can say that this function is not differentiable because the left hand limit and the right hand limit, they don't match. Okay.
Right, sir.
Yes. Yeah, Suman, you have any doubt?
Yes, sir.
What is your doubt?
Yeah, that is on activity 8.4. It's on the first problem, first question. So here, okay, yeah, here my answer is 9, but the correct answer seemed to be 15.
Which one?
The first problem on 8.4, activity 1. So see, basically they are adding the slope of the curve at the 3 points given. So I have taken the f dash of x.
Okay, so this is, I guess you have made some calculation mistake. Do it carefully.
Okay.
No, there is nothing in this question. Like you compute, the answer is correct.
Answer is.
Which question, sir, we are talking about?
8.4, question number 1.
Okay. Yeah, my f dash of x is 2x plus 3, sir. 2x plus 3.
2x plus 3. What is your function f of x?
Oh, okay, it's x cube. Sorry. Yeah, I took it as x square plus 3.
I guess, see, most of the question you are doing like that. Okay, so some silly mistake you are doing, and you are basically end up with a wrong answer.
Okay. Sorry, sir. Thank you.
Any other question from 8.4?
Nothing more from me, sir.
See, the thing is, okay, you have to be very careful in the exam. Okay, so if you like that, you know everything, but you will lose the whole mark. So I'll suggest be careful. Okay, this is fine if you are doing here, but don't do it in exam.
Yeah, got it. Yeah, thank
you. Pooja.
Sir, I have a doubt in 8.2, question 10.
What is your doubt in this question?
It is said that f is continuous, so we can just directly equate the limits. So is that the right way to solve the question?
Yes.
Okay.
That is the route. So the first thing is you have to assume that this function is continuous as well as differentiable, right? So just let me write the question. So you have a function f of x, which is, I guess, okay,
kx square plus L.
Square plus L if x is less than or equal to 1. So you have to first, by assuming that this function is continuous, and differentiable, you need to compute the value of this KLM, right? So the function is continuous and differentiable. That means the limit exists, right? The left hand limit and right hand limit at x equal to 1 exists, right? And what is the left hand limit? What is the left hand limit of this function at x equal to 1?
K plus L.
Correct. K plus L, right? And what is the right hand limit?
L plus K. K
plus K plus M.
L plus K plus M, right?
Yeah.
And so this both of them should be equal, right?
Yeah.
In that case, what you will get? M equal to 0, right?
Yeah.
So this becomes 0. Okay, we don't now, I can simply ignore it. So this I'm getting from basically, yeah. So for continuity, what you should get, this K plus L, this is left hand limit, this is right hand limit, and both of them should be equals to f of 1, right?
Yeah.
And f of 1 is, as you can see, K plus L, right? So you don't have to write it separately. So this you are getting from continuity, right?
Yeah.
Yes.
The next thing is differentiability. Okay. So what is the left hand derivative?
K plus 2kx.
What is left hand derivative at x equal to 1? Anyone?
Okay.
What is, I have
2k.
2k, right?
Okay.
See, this is left hand limit. Again, the left hand limit is basically means you are coming from the left hand side, right? That means the value is less than 1. Okay, in that case, the function is basically this. Okay, and if you simply differentiate this, what you will get? 2kx, right? And you are computing at x equal to 1. So if you substitute, then you will get 2k. X equal to 1, if you substitute here, you will get 2k. Okay, this is the left hand derivative. And what is the right hand derivative?
2l plus k.
2l
plus k.
Correct. Plus k. And they should match, right?
Yeah.
So if they should match means 2l plus k
is equal to 2k.
Okay, that means L minus k. So, no, not 2l minus k should be 0.
Yeah.
Right? So what basically it's asking, what is the value of k minus 2l plus n? This is 0, right?
Yeah.
Is it clear now?
Yes, sir.
Okay. Okay, anything else from Wicked?
Sir, can I ask some general doubts?
General, yeah.
Limits and continuity is new for me because I don't have a math background. So I am preparing for I have written some short notes for trigonometric functions and arithmetic operations on function like f of f plus g of x kind of things and standard limits of trigonometric limit. Exponential, logarithm. Okay. So these are the things, and I am preparing for like these activity questions and practice assignments and watching some YouTube videos regarding that. So these are enough, or should I change the sequence of preparing for it?
See, okay. See, if you are solving all the activity question,
I'm trying, but
no,
they are
that is the thing. See, solving activity question means not that you just remember. So see, in session actually we are solving most of the activity question. Okay, so the thing is you have to understand it. Okay, then if you understand all the activity question properly, okay, then you can do 100%. You can get 100% mark in the exam. Okay, because the activity question anyway we are giving much more easier question in the exam compared to this activity questions. Okay.
That is the thing now, because I'm trying, but I failed many times, but I try again to do the questions.
Yeah, that is good. So if you are trying, then certainly this is good. But again, like, see, you try to understand the question, like try to understand each and every activity question, how actually we are doing it. Okay, so
okay, sir.
Until unless you don't understand the thing, see, you don't have to remember much. Okay, so for example, there are very few things you need to remember. For example, the definition of the derivative. Okay, when you say so probably, yeah, in week 8 you have to remember two things. Okay, when the function is continuous, when the function is differentiable.
Okay.
After that, it's depend on your background, what you have studied from week 1 to 7. Okay, week 1 to 7. Okay. Whether you know, and few other things obviously you have to remember. For example, the derivative of sin x is cos x.
Cos x, right.
So the derivative of cos x is minus sin x. Okay.
Yes, sir.
So
I remember
these type
that.
of things you have to remember.
Yeah,
okay.
Like standard derivatives.
Standard derivative of e power x. Derivative
I
of
made a list of that also.
You don't have to make a list. Okay, if you
no, I'm just remembering now, because it is.
No, you don't have to remember. See, if you solve enough. See, I don't see, the thing is, why I remember derivative of e power x is e power s, because I have solved a lot of problem related to this thing. Okay, why I remember the derivative of a polynomial is what I have not written it somewhere, right? Because I have done enough problems so that I don't have to remember it separately.
Right, sir.
Since I have done enough problem, I don't have to remember it separately. See, all these things, see, whatever now I have solved, like this, not that I have studied some like yesterday or day before yesterday. It's not like that. I have studied it long back, but the thing is, I have solved a lot of problems. Okay, then so once you'll solve a lot of problems, then you don't have to remember much. So it's completely depend on your practice.
Okay, sir. One another thing is, like, the function is e to the power minus 1 by x square. So how we see that this function is composite?
E power
minus 1 by x square.
That we have discussed, right?
Yes, sir. So I want to know, if I see in a general form, I see that it is the power, e to the power. But as you said, it is in composition. Right. So how will I know that if some other function is given, like then how will I know it is in composition or not?
Again, like, see, if it is a complicated thing, then probably you have to think a little, then only. But for this type of function, it's really easy, right? See, what is so you know this function, right? F of x equal to e power x.
Right, sir.
Right. So instead of x, what? You have this thing.
Yes, sir.
Right.
Okay. Right.
So then it's clear that means you are actually composing this one, right? Because instead of x, you have minus 1 by x square. That means you are composing f of x, okay, with g of x. And what is g of x? G
is
of
minus 1 by x square.
X square, right? So what basically you will get? If you compose, what you will get? F of g of x, right?
Right.
What is g of x?
G of x is minus 1 by x square.
What is f of minus 1 by x square? This is minus of 1 by x.
Right, sir. Understood. We are putting minus 1 by x square in the place of x. Right.
Yes.
Okay.
So again, like, see, this is related to what?
Composition of function.
So, as I said, see, this week 7.
Week 6.
Yeah. So week 7, 8, 9 is completely depend what you have studied before. Okay. So if you have done it thoroughly, then see,
it will create problem.
Yeah. No, if you have done it thoroughly, then certainly it will not create any problem.
Oh, okay.
And also it depends. See, if you are studying it for the first time, or maybe after some
Long
gap
time.
of 10 years or years, then of course you will face problem. Okay, so this is yeah, so you can't do much about it. Okay, if you
Okay, sir.
practice
Lot of
lot
questions.
of question, then you can reduce the pain. Okay.
Okay, sir.
But if you are doing it for first time, or maybe after a long gap, then you will
Yeah,
face
for the first time, sir. I'm for the first
so
time.
then certainly you will face problem. Okay, it's very difficult to avoid, but you can avoid the pain. Okay, if you practice more, then probably you can.
Yeah, I'm doing the only this degree now, so I can give my time to
Yes,
this.
yes.
Okay, so thank you.
Okay, thanks. Any other question from week 8?
Sir, one doubt on the derivative of f, f of x plus h minus f of h divided by h. So yeah, this formula we are I see most of the times we rarely use. Is that because we can find the derivative in different ways? That is why we are rarely using this formula in most of the activity questions. I think we are using this only to find if LH left hand, left hand side is equal to right hand side. Except
see, we are of course we are not using, but again, like, see, if someone will ask you what is the derivative of x square,
I said 2
equal to x. Okay, but if I ask you how you are getting, then you have to come back. Okay, but again, many times what we are doing, we are simply saying 2x without basically we are ignoring how the fact how. Okay. So if you want to know how, then you have to come here. Okay. So, but when we are saying the derivative doesn't exist, so when we are saying the left hand limit is not equal to right hand limit in many cases, right? Or we are computing left hand limit sometimes and right hand. There is no other way of doing that. Okay, we have to use this method.
Okay. Yeah.
So it's depend what actually you are trying to achieve. Okay, so
yeah.
Okay, Mayank.
Hello, sir. I actually have a doubt from week 6 practice assignment. Can I ask? Actually, it's practice assignment, question number 6, option D.
Have you checked the solution, man?
Yes, I have seen the solution.
Question number
6, option 4.
Option 4. Yeah,
yes. Or I can maybe speak the question itself.
Yeah, you can see it on my screen. Yeah.
Right. Yeah, so it says there is a function such that log of fx is greater than or equal to 100, right? So I argue at one point, and that is if we look at the graph of the log function, then we can see that we have an asymptote. So this way we cannot have a minimum defined value for the function. We will always have an open bracket. So by this interpretation, we can say that log of any function can be greater than 100, but it cannot be greater than or equal to 100 because the minimum value is not defined.
Greater than 100, but you are saying log of f of x is greater than 100,
yes,
but cannot be greater than equal to.
Yes.
What do you mean by greater than or equal to?
Greater than or equal to, I mean that
it can be either greater than or equal to, right?
Yes.
So this greater than is a subcase of this one, right?
Yes.
So the greater one comes under this, right?
Yes.
So then if you can say that, so if you are saying that you have a function f of x such that log of f of x is greater than 100, right? That means this statement is also true, right? Because it's saying greater than or equal to. it can be greater than or equal to. There is a or, right? If one of them satisfies, that means this condition holds. And you are saying you have a function for which log of f of x is greater than, right?
So actually, it was kind of a bouncer for me. Can you explain again?
Just a minute. See, first of all, if you take f of x equal to 10 power 100, right? Then what is log of f of x?
100 into log 10.
This is 100, right?
Yes.
So that means you have a function f of x which satisfy this condition, right? Correct. And in this case, you have actually greater than equal to. See what I am saying. So, okay, this question has whatever I wanted to say, it has no connection with this question. Okay, it has some connection, but that is something general. Okay, see, if A is greater than B, what basically means A is
either greater than
or
equal to
B, right? That means, see, this is a inequality, right? This is a inequality. It basically says if A is greater than B, right, then also this is true, right? If A is equal to B, then is also this is true.
Yes.
Right. So you have two things. If one of them holds, then this inequality is true. For example, I can say that 2 is greater than or equal to 3. Right? So see what basically is saying. Okay, this is a mistake. Okay, I wanted to write 3 is greater than or equal to 2. Right? See, even I can write the same thing. 3 is greater than 2. Right? So this actually this one is saying what? 3 is greater than or equal to. So in this case, actually 3 is greater than 2. Right? And that's why this is correct.
Yes.
Right? So similarly, when you are saying log of, you have a function f of x which is greater than 100. So if this is correct, right, then this is also correct, right? Because what you are saying, this basically means log of f of x is either 100 or
greater than
100, right? See, if one of them holds, that means this is a correct statement, right?
Yes.
But according to you, this one holds, right?
Yes.
So that means this is a correct statement.
Okay. Now I got it.
See, this is actually this A greater than B. So this is sort of like a union.
Yes.
Right?
Yes.
See, you have two conditions. If one of them holds, then this is a correct statement, right? That is what I am saying. When I am writing 3 is greater than or equal to 2, right? This is a correct statement.
Yes.
Why? Because this is considering two things, right? This is true when this satisfies this condition or
equal to 2.
But in this case, this doesn't hold, right?
Yes.
But this holds.
Yes.
Right? So that's why this statement is correct. Okay. And when I will write 2 is greater than or equal to 2, right? This basically what? This consider two things. Either 2 is greater than 2
or 2 is equal to 2.
2 is equals to 2. But this one is certainly incorrect. This one is correct. That's why this inequality is correct.
Yes, okay. Now I got it. But I have one different question similar to this, and that is, can we really have a minimum defined value for log function?
No. For log function, you can't have.
Okay.
For log, see, there is a different thing. Here, as you can see, I'm composing two different things. Okay.
Yes.
If you simply take log of x, okay, then you know the graph, right? It has no, if suppose the base is, okay, if the base is 10, then you don't have minimum, right? It's going towards minus infinity, right? But if I take some function as I have taken 10 to the power 100, okay, in that case it has a minimum value, that is 100.
Okay.
Clear now, or like?
Yes, clear.
Okay,
thank you.
Okay, anyone else? Hello, sir.
Sir, my doubt is from week 6. May I ask the question, sir?
What is your doubt?
Sir, practice assignment. Some question related with log. That is practice assignment question number 6. Question number 12. Practice assignment 6. The question is from is log of logarithm, but I am not able to solve this question.
Have you checked the solution?
Yeah, sir, I've checked, but I could not able to understand this.
Yeah, well, which part? Okay, let me open the solution. Which part you are not able to understand this? Let me know.
Sir, question number 12. The same question is in mock 4, right?
Just a minute.
Sir, can I ask question?
No. Just a minute. Let me open that file and let me solve this question. Yeah, can you see my screen? Okay, no. Tell me where you are facing the problem. This is the solution, right?
Yes, sir.
Where you are facing the problem in the solution? Tell me where you are facing the problem in the solution. Which step?
First statement, first line and the second line. Basically, first and second line.
So to find the values of x, that's satisfying this equation, right?
Yes, sir.
So if you take this, what is log a base a?
1.
1, right?
Yes, sir.
Okay, so just a minute. So basically what actually...
So the same concept is in mock 4 question. Which
the concept is MC. Okay, so let me write actually. See, basically they are applying log of 5x, okay, in both the sides. Okay, that's why they are coming to the second step. See, you have this, right? This is your log of 5x 1 by x, right?
Yes, sir.
And you have something here, right? This is 1. Correct or not? This is the statement. Now you apply.
Yes,
now you apply
5x to the power 1 by 5.
Log x 5x. Okay. Log
5x to the 5x to the power log base 5x to the power 1 by 5 and bracket 6x.
Just a minute. This is, suppose this is the whole thing is b. Okay. So
बंद कित करा है?
Please mute yourself, officer. So in the right hand side, what you will get? 5x 1, right?
Yes, sir.
So this is, what is this?
Both equations are equal.
No, what is the value of this one? X is what? X is positive, right?
Yes, sir. It is positive.
So what you will get? So
positive value.
0.
This is 0, right? See, log of A1, what is this? This is always 0, right? If A is positive, this is always 0, right? Because A power 0 is 1.
Okay, yeah.
So this is this. So if I apply log of 5x, this right hand side is 0, right? Correct or not?
Yes, sir.
So what about the left hand side now? What you will get here?
Log b is equals to 1.
Log 5x power some alpha. What is this value?
5x to the power alpha. Only alpha.
Alpha, right? So here you have what? So here b is what? 5x power this thing, right? So you will get this quantity, right?
Yes.
What is that quantity? That quantity is log and some polynomial, right? Correct. Now your first step is clear.
Yes, sir.
Right. Now if, now you tell me, if log of A of B is 0, okay, what will be the value of B?
1.
Equal to 1, right? So here log of 5x, so this is your B, right? This is your B and this is your A, right? Now A power B, log of B base A is 0. That means your B should be 0. So B should be 0 means what? 6x cubed minus 316x square power 1 by 5 is 0. And you can remove this 1 by 5. Okay. So this is your 0. So now the second step is clear.
Okay. Yes, sir.
Now you can proceed, right? Now
Yes,
basically you need to just solve this polynomial. Okay,
polynomial. Yes. Okay, thank you, sir.
Yes. Any other questions?
Hi, sir. Pradeep here. One question, sir. I mean, 8.4 activity, question number 8. 8.4, question number 8. . 8.4, question number 8. 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 8.4, question number Yeah, so I'll just explain the steps what I did. I don't know what mistake I'm doing. I'm getting 5.16.
So at which point you are computing the tangent? You have a function, right? F of x equal to 1 plus
x power 4, yeah. So what I did, sir, first I did f of 0 equal to 1. Okay.
And you need to compute
f dash of x.
You need to approximate the value of 0.014, right?
Sorry?
You want to find the you want to find the approximate value of this one, right? 1.01 power 4.
Or 4, correct.
Yeah, what you are doing now, tell me. Yeah.
Okay, sir. Yeah. So what I'm doing is like first, because it's given x at x equal to 0. So what I did is like I first computed f of 0, which is coming to 1 power 4, which is equal to 1. So that is 1. Then I did f dash of x, which is equal to 4 into 1 plus x power 3. Okay, and if I compute f dash of x at 0, that is coming to 4.
Correct.
So, okay, so this is what I got. I got f of 0 and f dash of 0. Okay, now what I did is like y equal to...
you need to compute the tangent, right?
Yeah.
What is the tangent?
Okay, so here y equal to f of 0 plus
f of 0 is 1.
1 plus f dash of 0, which is 4, into x minus 0. Into no. I mean 1 plus 4 into x minus 0, right, sir?
Yeah, it's 1 into 4 minus 4 into x minus 0.
1 plus 4 into x minus 0.
This is f dash, which is 4 times x minus 0.
Correct.
Plus
Yeah.
f of x.
F of 0. Correct. 1. Yeah. So this is what I got finally. Okay. Y equal to 4x plus 1. Yeah. Now I try to compute for 1.01 power 4. Now if I do 1.01 power 4.
What you need to substitute?
I mean, in that equation, I have to substitute 1.01 power 4 for the x value.
No, for the x value, you need to substitute 0.1. See, if you substitute 0.1 here in f of x, right, what you will get? If you substitute 0.1 in your function, right, what you will get?
Yeah, I will get 1.01 power 4.
1.01 power 4, right?
Yeah, correct.
Just a minute. So you have a function, right? Whatever this function is, f of x. Right, this is your function.
Okay.
1 plus, okay, this should be slightly above of your x-axis. 1 plus x power 4, right?
Yeah.
And you want to compute 1.0.1 power 4, right? So let's say this is your 0.1.
Okay.
And this value is f of 0.1.
Okay.
Right? So this is precisely f of 0.1 is precisely this value, right? And you are taking the tangent, right? At x equal to 0, right? Right? So if you substitute in the tangent, if you substitute 0.1, okay, then only you will get a value closer to f of 0.1, right? If you substitute 1.0.1, you will get a number which is far away from f of 0.1, right?
Okay.
So instead of substituting 1.0.1, you need to substitute 0.1 because the function is already 1 plus x power 4.
Okay.
Are you getting my point?
Yeah. I'm getting. Okay, so okay, whatever value that was given, it is based on that function. We have to derive the actual x value and substitute.
Yes.
Okay. Okay, sir. Got it, sir. Yeah, I think I missed that part. Okay, thank you.
You can see, right? If you take the tangent here, okay. If you take the tangent here, right, at x equal to 0. So this is your f of 0.1, right? And if you substitute 0.1, then only you will get a value close to this f of 0.1, right? So, but if you substitute 1.0.1, you will get a number which is far away from that number, right?
Yeah, got it. Got it. Yeah. Okay, sir. Thank you, sir.
Yes.
Sir, I have doubt from week 6.
What is your doubt in week 6?
Sir, activity questions. Sir. Activity question 6.3, question number 2, sir. Sir, there are few more doubts.
Question number 3.
Yes, sir.
6.3, question number 3.
3 and 4. Sorry, 3, sir, 4. 6.3, question number 4.
Have you attended the live session of week 6?
No, sir. Actually, sir, I am lagging behind. I'm still completing my week 7.
Yeah, that is fine, but you should check the live session recording, right?
Sir, sorry, but actually I get less time and I'm not able to find that question in
okay, no problem.
Particular session is too long, sir, and completing the whole session is quite a bit difficult for me.
See, whatever, like you have, in the end, you have to spend time. Okay. If you can't spend time, then so you want to solve this one, right?
Yes, sir.
So when e power a is 1,
that is 0, sir. 4x minus 2x 2 to the power s.
This implies 4 power x minus 2 power x minus 12 is 0.
0,
right?
Yes, sir.
So this I can write as 2 power
2x common and 2 to the power x minus 1. Is
correct?
Yes, sir.
So now you take a equal to, not a, maybe say m equal to 2 power x, right? If I take m equal to 2 power x, then what this will become? M square minus m minus 12, right?
Okay.
Now if you solve this one,
4 and 3, it will come 4 and 3.
this will come m minus 4 m plus 3 equal to 0, right?
Right, sir.
That means m equal to 4
minus 3
or m equal to minus 3. That means 2 power x equal to 4 or 2 power x equal to minus 3. If 2 power x equal to 4, that means x is equal to log 2 4, which is 2, right?
Okay, yes, sir.
Do you think this has any solution? 2 power x equal to 3 minus 3. This has no solution, right?
Okay.
See, 2 is positive.
Yes,
2 power x is always positive, right?
Yes, right, sir. Right.
So this has no solution, right? So you have only one solution, and this is the solution. Clear now?
Clear, sir. Clear. Yes. Sir, one more. 6.2, question 3. Sir, how to approach this one? I'm not able to find the way.
See, again, like we have, I myself has discussed all this question. So,
okay, sir, if you getting late, then it is okay. I will find.
No. Just if you have, well, at least let me explain this question.
Also, if you are having less time, then please make me understand the limit, the continuity of a function at some point. So I didn't get this through the lecture.
No, I have discussed it a lot of times. Okay, you try to revisit the videos, say live session. Okay, so before that, okay, so let me explain this question.
Okay, sir.
How many logs you have? Right?
Yes, sir.
So you want to find what? You want to find the domain, right?
Yes, sir.
So when this log of is defined, if x is greater than 0, right?
Yes, sir.
So instead of, so here you have x, right? So instead of x, here you have this part, right?
Yes, sir.
Right, instead of this, so you want this whole thing to be greater than 0, right?
Yes, sir.
You want this to be greater than 0, right? So when this is possible, if and only if you take 2 power,
yes.
If you take 2 power this side and as well as this side, what you will get? You will get log 2x greater than 1, right? Right or no? Hello?
Yes, sir. Yes, sir. I am listening.
So again, if you take 2 power this side and 2 power this side, what you will get? X is greater than 2, right?
Right, right, sir.
So that means this function is defined
when x is greater than 2.
Yes.
Okay. So, sir, f is one-to-one function.
See, okay, so as you can see, this is composition of log function, right? You have actually taken the composition of multiple log function, right?
Right, sir.
This is what? Log 2, composition with log 2, composition with log, right? Correct or not?
Yes, sir.
So you have 3 log function and you are taking the composition, right?
Right, sir.
So you know that log is injective function, 1-1 function.
Yes, sir.
So this is a 1-1 function, this is a 1-1 function, this is a 1-1 function separately. Okay. So one fact is, so what actually we are using here, composition of, actually this is a fact, composition of 1-1 function is 1-1.
Okay, sir.
So that means if I compose this log, so here I have composed 3 times. If I compose it 10 times also, I will get a 1-1 function. Okay. It doesn't matter how many times I'm taking the composition. Composition of 1-1 function is always 1. Okay. Since this is 1-1, this is 1-1, this is 1-1. So whole composition, which is f of x, is also 1.
Okay, sir. Sir, one more question. Activity 6.5, question 1. How many digits are there in 15 to the power 7?
Again, like, yeah, I'll suggest you go back and check. Okay, I have explained this question in details. Okay, you should see the first session of, I guess, 6.5. See, I have explained this. I have solved actually all the question of 6.1. Most of the question of 6.2, including this question. Okay, mostly I have solved the activity question. Okay, you try to
Okay, okay, no issue, sir.
check that.
Okay, okay.
Okay.
Thank you very much, sir.
Thanks.
Okay, good night, sir.
Good night. Okay, I'll stop the session.
Okay, right.
Thanks.
Good night.
Thank you, sir.
Thank you.